Without any further ado, let's go ahead and welcome Connell to the stage if he's ready. Tell us about build face tracking.
Thanks for the introduction. Yes, I'm Connell, the CTO here at Zappar. Now, at Zappar, for the last 10 years or so, we've been building content and tools for the AR industry. And indeed, our platform, ZapWorks, has been empowering developers to build content for many years and across the world now. Our mission at Zappar is to democratize AR. And that's why this summer, we've launched Universal AR, which is a completely new set of SDKs and libraries designed to make it easy to build content using whichever tools you wish. Now, today in the talk, we'll be doing a live demo and producing two AR experiences using our Universal SDK. But before I go into more about that, I thought I'd just give you a quick rundown of what the Universal AR SDK is and how you can use it. So without much further ado, this on a slide, I suppose, is Universal AR. Now, there looks like a lot here, but I'll take you through it quite quickly. So on the left, we have the different tracking types that our Universal AR support. So image tracking, face tracking, and what we call instant world tracking, which we'll come on to in a minute. But the magic of Universal AR is that we provide these tracking technologies, but you can use whichever content tool you wish to use to build your experience. So for example, we support ThreeJS and A-Frame on the web. We support Unity, where you can export your projects for iOS or Android natively, but you can also export using the WebGL output. So with Universal AR, kind of for the first time, you can build image tracked, face tracked, and world tracked experiences, and you can export them instantly for the web from Unity without having to worry about an app store process, which is pretty incredible. And thanks to Universal AR, but also the power of the browsers that we have in mobile phones these days. So if you use, for example, our ThreeJS or A-Frame SDKs, you can build AR content for the web using those. But if you're using a different toolkit that we haven't provided an SDK for, that's fine, because we also provide a vanilla JavaScript library that you can use with whichever framework you like to build your content. Now, when it comes to distribution, we support all of these tracking types in the normal browsers that users have on their mobile phones. So it's not some fancy special version of Chrome that the user has to download. It's literally the Google Chrome that's been running on their phones for years now, or the version of Safari that's been on their devices since iOS 11 that these libraries support. So you really have a huge target audience of mobile smartphone users when it comes to using these technologies. So why don't we build some content? That's probably the best next thing to do. And the first piece of content we'll build is with A-Frame. Now, A-Frame is a fantastic library. It's an open source library for the web, and it allows you to build AR and VR experiences using components in HTML. So it's quite easy to use. Now, thus far, if you've wanted to use AR with A-Frame, you've had to rely on the WebXR API, which is only supported in the absolutely most recent version of Google Chrome, but also has no support on iOS. Whereas if you use Universal AR and our SDK for A-Frame, then you can support all of the older versions of Chrome, but also you can support iOS. So you get the advantage of those additional tracking types, as well as the ability to target a larger group of people. And to demonstrate just how easy it is to build some content with this, I thought I would do it live. So let me just bring us out of the presentation. And I'm going to pop back here to Visual Studio Code. Now, I use Visual Studio Code. You can use whichever development environment you have at home in your own cupboard. But here we have what is, if you like, a very simple A-Frame project. It's an HTML page, and we can see we just include A-Frame at the top here, and also Zappar's Universal AR library for A-Frame here. And then a very typical A-Frame page here. There's a scene. There's some assets, in this case, some glasses. There's a camera, and there's a group or an entity in A-Frame terms, and then a 3D model of the glasses is included in that group. So nothing Zappar yet here, but we can turn this simple file into a proper face-tracked experience really quickly. So the first thing we do is we just add Zappar camera here to our camera. So we're adding another component to our camera object to make it the Zappar camera. And in fact, because we're taking a face tracked experience in this case, we're going to make it use the user facing camera, just like that. Now, all we have to do to make this group here tracked to my face in this experience is literally to type Zappar-face here. So that component does absolutely everything to turn this into a face tracked experience. And we've already got our model in here, and it's already scaled and positioned in the right place because I was expecting that we would be doing this demo. So hopefully these glasses should fit in the right place. So if I save this file now, and then I'm going to use a command line tool that comes with our libraries, which will let me serve this content so that we can give it a try in a browser. I'm going to hit serve there. I'm going to pop over to Google Chrome here. I'll just reload this page. Because I'm serving over HTTPS, which is a requirement for accessing the camera, I'm using a self-signed certificate, so I get this scary warning here, but it's nothing to worry about as long as you're happy that it's your own computer, which in this case it is. So I'm just going to proceed past that warning and load up this page. And here we go, a face tracked experience. I'm not wearing sunglasses, so in A-Frame. Now, just to prove that this works well on a mobile device as well, I have a mobile device right here, and I have it loaded up so that you can see on the screen what I see. And I'm going to open up Safari on this device. I'm just going to press reload on this. See the same connection warning here, of course, on Safari. I'm going to proceed past it. Now, there is a weird bug that Safari has where when you do this, you have to quit out Safari and try again. But now that we have, I get the permission prompts to allow the camera. And then here we have my face tracked experience running in Safari. And so it's pretty buttery smooth. So it's like at least 30 FPS here. This is running on an iPhone XR. So a relatively modern device, but certainly one with a lot of market penetration. And of course, it works fantastically well on Android as well. So I'll close that here. Now, there's one other element of our face tracking that I thought I would show you, which is in addition to being able to place content on or around someone's face, our face tracking also allows you to add a mesh that fits their face. So I've got a little cheat sheet here just to put this into our A-Frame experience, but here we have another A-Frame entity in addition to our glasses, and this just has a face mesh geometry attached to it. And I've also got a little texture, which we'll put on top. And if we save that and go back to our Google Chrome and then reload our page, we should see, in addition to the glasses, a face mesh that fits my face and follows it running in the browser. And just for the encore on a mobile device, if I reload that page as well, give it access, then there we go, running again, full frame rate in the browser with full face fitting mesh. Cool. So as you can see, like super fast to build some content here. You can, of course, script this with JavaScript to react to events that happen. And of course, this is just a face tracked experience, but we also have the other tracking types for A-Frame. So I'm just going to pop back to my presentation very briefly. And talk next about ThreeJS. So my next demo is going to be with ThreeJS, which is a 3D content library for JavaScript. So it lets you build 3D experiences in JavaScript without having to worry about WebGL or all of the guts like that. It supports 3D models, a ton of 3D model formats, supports lighting, shadows, everything you'd expect from a proper 3D engine. And now with our Universal AR SDK for ThreeJS, you can use ThreeJS to build AR experiences. And in this case, in addition to it supporting image tracking and face tracking, this time we're going to make an instant world tracked experience. So you might be familiar with the type of tracking that ARKit and ARCore provide you. We call that world tracking, where it allows the user to place some content in the environment around them and move around it. Instant world tracking is a very similar type of technology where it lets users place content in the world around them. It's instant because it doesn't require the user to kind of wobble their phone around to find a plane before they place the content there. But the other side of the coin from that is we don't get scale from the absolute scale from the environment. which means that it's not really good for making a portal experience or an environment that the user walks around in, but it's great for making experiences where you have a 3D model that you preview and look around, or you have an animated character that you can interact with. So in this case, we're going to build a little ThreeJS experience that looks at a character. So without much further ado, we're going to close out of that and pop to a different example here. Now, in this case, well, I should say before with A-Frame, it was just a single HTML page. In this case, we've got a much more opinionated project, much like the kind that we use at Zappar. So we use tools like Webpack to help us distribute and build our projects. And we use TypeScript, which is an alternative to JavaScript, I suppose, that helps you build JavaScript applications really easily. So this project is set up with Webpack and with TypeScript and with ThreeJS. And indeed, here is our index.ts file, so our equivalent of our index.js file, if you like. We're building a JavaScript experience. And it's a fairly typical ThreeJS project, this. So we have a renderer at the top. It's set to appear at the right size in the browser window. We have a scene. We have a GLTF, so that's a 3D model file we have here placed into our scene. We have a render loop, so this gets called once a frame experience. So thus far, this is just a normal ThreeJS experience. But to bring instant tracking to this experience, we can do so pretty easily. So first thing is we can import our Zappar library. So the libraries are all available. You can use like our CDN, like we saw in the A-Frame example where there's a script tag, or you can use, you can download like a standalone bundle, or in this case, we also distribute our libraries as packages on NPM. So you can literally just go npm install @zappar/zappar-3js to get started. So we'll import it into our project like this. Now, normally in 3JS, you have a camera, and in this case, we're going to create a camera using our library, 3.camera, simple as that. Our library also needs to know the WebGL context of your experience. So GL context set, and we can get that from the renderer object like this. That's just a little bit boilerplate we need. Then we can set our scene background to be the background texture that the camera provides. So the Zappar camera provides a background texture, a 3JS texture that you can set to the scene background so the camera can be seen behind your content. Then if we have a little look down, there's a couple of little elements we need. So in our render frame, we need to tell the camera to update itself. And we pass the renderer in there. And then we just need to decide what kind of tracking we want to do. So we already decided we'd like to do some instant tracking. So let's add that in. I'll just call it tracker. And we can just create that with a new Zappar.3 instant tracker, instant world tracker. There we go. That's an object that lets us configure how our tracking works. But with 3JS, we can also create an instant tracker group, which Zappar3 dot instant world anchor group. There we go, tracker. And what that will do is give us a group that we can, who else needs the camera? So we'll pop that in there. That gives us a group that we can put 3JS content into. So it's just a 3.group behind the scenes like you would be used to with the 3 framework. So, and instead of our 3D model here, which is being loaded in this line, instead of it going into our scene, we're going to put that into our tracker group. And then, of course, we're going to make sure that the tracker group is in the scene itself. So basically, what we've set up is that this character here should appear within our instant world anchor group and be tracked to the environment around us. Now, as we'll see in a moment, what the world anchor lets us do is let the user choose a place to position the content. So to facilitate that user interface, in our index file, we've put a little bit of UI saying tap here to place the object. And so in our index JavaScript or TypeScript, we will listen for that to be tapped and then change behavior depending on whether the user has done so or not. So on my cheat sheet here, I have a little bit of code just to do exactly that, which I will talk through. So we get the element from our HTML, which is the placement UI element. When it's clicked, we remove that element from the UI. And we're also just changing this variable has placed from false to true. But then the magic comes in our render loop. So inside our render loop, we can go to our tracker and we can say set anchor pose from camera offset. Now what that means is that whenever this is called, the center of our instant tracker group will be placed at the point in camera space referred to in the arguments here. So I'm just going to say 0, 0, -5. And what that means is if I've got the phone camera here and I'm looking around, every frame, the tracker group's position will be set just to be in front of the camera, like -5 units in Z, so right in front of the camera, which will allow the user to position and place the object as they look around. But once they tap on that, once has placed is true, we want to stop doing that. So only call this function if has placed is true. So if we save that, let me just go back to the A-Frame one to close down the server that was running there so that I can run an equivalent server here. In this case, this server is using the Webpack dev server since we're using Webpack. So if I go back here and reload the page, I'll probably get another security warning, maybe not. All working correctly. Oh, no, there's one final thing that I forgot to mention, which is camera permissions. So with the ThreeJS integration, you get much more control than you have in A-Frame over how the camera permissions work. But to make things much easier, the Zappar component comes with a nice UI just to make it really fast for you to request permissions from the user. And that returns a promise, which lets you know if they've granted the permissions. And if they have granted the permissions, we can start the camera, which is what wasn't happening before. And if they haven't, we can run another little helper function for permission denied UI, which is another little helper UI that the Zappar library provides. So if I save that, the Webpack server is automatically recompiling my TypeScript here. If I return back to this, we have a grant access permission here, and here we go. Now, my device doesn't have a gyroscope, my laptop here, which is why this experience doesn't look right yet. But if I pop to QuickTime again, and we have a look at the phone running this experience. So if I just hit reload on this, with any luck, we have a non-responsive, let me grab that URL, copy. It never works on the final demo. Okay, let's try this again. Close that. Let's restart Safari and place this back in. Okay, here we go. We'll grant access, allow motion, allow camera. Here we go. So we have our ability to look around to choose a place. And when I tap it, this is now a world tracked 3D object in our space. And that is again like full frame rate, so like at least 30 frames per second on this device. And indeed, my Android is like a 2 or 3 year old Android device, and OnePlus 6, I think it is. It's also full frame rate there. So really kind of well performing instant tracking there. And of course, we're not demoing, but it's totally present image tracking. So tracking arbitrary images in 3D space, also supported by the library. Cool. So let's pop back to hopefully from current slide. We've done the demo. So just to summarize, Universal AR is our new suite of SDKs for building AR, VR content. It support a ton of creative platforms. So ThreeJS, A-Frame, Unity, JavaScript, C++. If there's one here listed one here that you use that's not listed, then you can quite possibly use our underlying versions of these SDKs to add support to your own platform. But we are also going to be looking at platforms going forward that are popular for the web or for native, so that we can better support them with Universal AR. So you can get the SDKs straight away from our site and get started. We think it's a really important step towards democratization, having AR possible within the browser, the same type of AR that you would get in native apps. So you're not restricted to given platforms. And we think Universal AR is a really good step towards that. Well, thank you for watching. It would be great to answer any questions that you might have.
All right. Great presentation, Connell. That was some cool magic you just did there, by the way. And doing a live demo, that also, props there. So The one looks like we have a question. I know that is on a lot of folks' mind, given the developer environment. But I have developed an AR application in Unity. Can this be converted to web AR? And so if so, like how?
That's a very good question. And the simple and non-technical answer is yes. The more technical answer is there are, of course, constraints, which is that Unity is a huge game environment or development environment. The assets that you build, the experience you've built in Unity might not translate directly into the web without modification. But certainly from the APIs that we provide, the universal SDK, switching from an existing native project into a WebGL project is literally just as simple as changing the build type to web. So if you're using our SDK, there's no difference between the web and native. Unity as a platform, your project may need some modifications to work with Unity's WebGL output. And indeed, Unity for the moment consider their WebGL output to be an experimental technology, but we've seen some really great uses of that technology already, and something I expect to get better going forward. So yeah, simple answer is it should work. The complex answer is it might take a little bit of tweaking.
And then just a couple more questions to make sure. How does Universal AR's world tracking work on Android? Is there just plain AR core with plain detection in the background, or some custom SLAM solution?
Yeah, no, in the web browser, we don't have access to AR Core. So
Right.
in world tracking on our Universal SDK is entirely our own world tracking technology. And we use the same tracking technology in our native versions of Universal AR as well. So if you're integrating Universal AR into an iOS or Android app, or if you indeed you use Unity and build for iOS and Android natively there as well. And in those cases, we use exactly the same algorithms that we use in the web. And so we can target devices that are that don't support AR Core. So for example, lots of the Android devices sold in China do not have Google Play services, and so don't support AR Core experiences. Universal AR should be able to support them, no problem. Now, I should stress that our world tracking offers a different type of world of experience to AR Core. So, as you say, AR Core does full surface detection and tracking of your entire environment. In its current iteration of our world tracking, it's a bit more simple. So it doesn't understand the scale of your environment. It will place content into a space that the user chooses and tracks it there. And this allows us to do this at full frame rate on mobile devices, which is in the web browser, I should say, which is really important. But we are, of course, continuing to work on our world tracking to make it more, to get closer to that full world tracking that you get with ARKit and AR Core. That's a really non-insignificant challenge for the web, where we don't have access to the same level of motion data that devices have. We don't have access to calibrated data. So it's a real tricky challenge, but for the moment and for many use cases, our current instant world tracking is a perfect solution, and one that runs 30 FPS plus on inside the web browser on modern smartphones.
Yeah, web for the win. All right. So, Connell, thank you so much. How do people get in touch with you to continue asking questions or just follow your work?
Well, you can head to our website. So our kind of corporate website, if you like, is zappar.com.
Yeah.
Alternatively, if you're interested specifically in our content creation tools, you can head to zap.works, which has all of our universal AR SDKs for you to get started with and download. In addition, we have a complete creative set of tools for building content. We have a studio tool that is a 3D environment that lets you build content targeted for the web and native. Those are more fully featured development environments, whereas Universal AR are low-level SDKs for those developers who are looking to integrate them within other platforms that they use. So yeah, head to the website.
Awesome. All right. Well, Connell, thank you so much for joining us at AWE Online 2020. Stay healthy out there.
Thank you for
And
having me.
we're going to move
Yeah.
on to our next presenter. So thank you very much.